polar form of complex number. Now let's say you have a circle, right? Now let's treat the center point as a point of observation. To identify the location of something or somebody on the circle, what are the pieces of information we require? We require basically two pieces of information. One is the distance, yes, from the center, and the angle from a initial line. So we can treat any particular point on the circle connected to the center as the initial line, and from that initial line we can figure out the angle. Information are, one is, let's say, r, the distance from center. Other is the angle formed from an initial side. Okay, the center is called the pole, right? So let's see how to figure out the polar form, right, of a complex number. Let's look at this. Now let's say this is the point at which the object is. Now we want to figure out the polar form of this location. Now this coordinate system is your complex coordinate system. Now let's say this is a plus ib, right? A plus ib. This is the angle theta formed, and remember we know that this is b, this is a. Sin theta is equal to what? And this is r. Sin theta is equal to what? Sin theta is equal to opposite by hypotenuse. Cos theta is equal to what? Is adjacent side by r. That means we can say a is equal to r cos theta, b is equal to r sin. Remember our coordinate system is a comma b of complex plane. So this particular point is a comma b. So we should actually write it as a comma b. Okay, so this can be written as r cos theta comma or sin r sin theta. In other words, a plus ib can be written as r cos theta plus r sin theta I. Okay, so let's take out the common term. So cos theta plus r, no, not r, I sin theta. A plus ib is nothing but the complex number. So this is called the polar form of the complex number. Yes, and to actually figure out the position, we require the angle theta needs to be in the range of only a single circle. Yes, We just need to know, because the object can be anywhere on the circle. So we are interested only in one circle, not in repetitive circles like normal trigonometric unit circles. So our domain for this would be from 0 to 2 pi, right? That is, if we only go in the anti-clockwise direction, or it can be minus pi to pi. That is, if we go like this, if we go like this here in this direction, and we go in this direction for the angles from pi to 2 pi, we go in the clockwise direction. For 0 to pi, we go in the anti-clockwise direction. Okay, let's see how to represent 1 plus I root 3 in the polar form. Right, now we know that A can be represented as r cos theta. In case of A plus IB, A is nothing but cos theta. Remember, this is xy coordinate is A comma B. So A is cos and B is sine. So 1 is equal to r cos theta. Root 3 is equal to r sine theta. Remember, 1 is A, root 3 is B. Now let's square them and then add them. 1 square plus root 3 square, r square sine square theta plus cos square theta. Now this becomes 1, so we can ignore it. 1 plus 3 equal to r square. So r is equal to square root of 4. We ignore the negative root because r is the modulus of the complex number, so it can't be negative. Now let's take that again. 1 is equal to r cos theta. This is, by the way, 2. So 1 is equal to 2 cos theta it becomes, and root 3 is equal to 2 sine theta. So we can say cos theta is equal to 1 by 2, sine theta is equal to root 3 by 2. Now for what angle of theta are these two conditions satisfied? Now remember, in the unit circle, as far as cos theta is concerned, it is 4 by 4, 3 by 4, 2 by 4, 1 by 4, 0 by 4. So cos theta is 1 by 2. That means this one, that is 60-degree angle. Pi by 3. So think about it. Cos pi by 3 equal to half, and sin pi by 3 is root 3 by. So our polar form of this is r, which is 2 cos theta. So cos pi by 3 comma, no, not comma, plus I sine pi by 3. So this is the polar form. Okay, let's take another problem. Polar form of minus 16 by 1 plus I root 3. Now let's rationalize it. 1 minus I root 3 by 1 minus I root 3 minus 16 plus 16 root 3 I divided by I square minus root 3 square. So what will happen? Minus 16 plus 16 root 3 I divided by 1 plus 3. Let's take common out. So 1 minus, no, let's not take minus out, minus 1 plus root 3 I, and denominator becomes 4. So 4 fours, minus 4 plus root 3 I. So now let's convert it into polar form. Minus 4 is equal to r cos theta. 4 root 3 is equal to r sin theta. Now square it and add it. (16) plus 4 fours are 16 into 3, 48 equal to r square. Cos square theta plus sin square theta is 1. So r square is equal to 8 plus 6, 14, 1, 4 plus 2, 6. R is equal to 8. Now that we have got r, let's substitute it. It becomes 8 cos theta and 4 root 3 is equal to 8 sin theta. That means cos theta is equal to minus 4 by 8, which is, and sin theta is equal to 4 root 3 by 8. So cos theta is equal to minus half and sin theta is equal to root 3 by 2. Now remember, in our unit circle, sin is positive, positive, negative, negative. Yes. Whereas cos is negative here, positive here. So this is where in the second quadrant we have cos theta negative and sin theta positive. And we know cos theta is half at 60 degree. That is pi by 3 here. So on this side it will be here. Right, reference angle is 60 degree, but the actual angle we require is in the second quadrant. So which means, sorry, pi minus pi by 3. So theta is equal to pi minus pi by 3. So that comes to 2 pi by 3. So polar form of this, what is the original? This one is 1 plus I root 3 is r cos theta. R is what? 2. No, 8. 8 cos theta. Cos theta is cos 2 pi by 3 plus I sin 2 pi by 3. So this is the polar form of minus 16 by 1 plus I root 3. Let's do 1 or 2 more. 1 minus I right? 1 minus I. Let's convert it to polar form. 1 is equal to r cos theta minus 1 is equal to r sin theta. Square and add. 1 square 1 plus minus 1 square 1. R square sin square theta cos square theta becomes 1. So r square equal to 2. So r is equal to root 2. Now 1 is equal to 2 cos theta minus 1 is equal to 2 sin theta. So cos theta equal to 1 by 2 and sin theta is equal to minus 1 by 2. When are they both? Now root 2. R is root 2. Right, so it is 1 by root 2. So when first of all, the moment you see that sin theta and cos theta both are same, that means it has to be 45 degree, and if both of them are positive, then it has to be 45 degree. Otherwise, you have to look at the other quadrants and the reference angle. Okay, we know the unit circle, when both are same, sin theta and cos theta, the absolute values are same, that means it is 45 degree. So it will be here, here, here or here. Now we have to figure out the sign. When is sin theta negative? Sin theta is opposite side, that means y. So that means it will be positive here, negative, negative. Now when is cos theta positive? Cos theta is positive here, negative, negative, positive. So sin theta is negative, cos theta is positive. That happens only in this quadrant. That means this is the angle we are looking at. So we can say 2 pi minus 45 degree. So theta is equal to 2 pi minus pi by 4, which is what? 8 pi minus pi by 4, which is 7 pi by 4. So the polar form of 1 minus I is equal to r, which is root 2 cos theta, cos 7 pi by 4 plus sin 7 pi by 4. Don't forget the I. So that's the polar form. Enough for today. Bye for now.